So Spark session is typically there is some noise actually. So
Yeah. I think somebody has to mute. I think a lot of noise.
that just muted. Ajit, I was just muting you for a while. There is some noise from your end. Just ping me when you. Okay. Yeah. So Spark session is entry point to database. Okay, and how do you use it? From PySpark SQL import Spark. Yeah. So with this, you'll be importing this Spark session. Okay.
So Spark session is only in PySpark.sql module or in other classes?
Right. It is only in PySpark. This one. Okay. Then what you are trying to do, you are trying to create a say Spark object out of it. Okay. So this is a class, and I'm doing a builder, and you do a master. Okay, this is happened by default here. Okay, if you see, if I write this right, automatically this Spark object is automatically created here. Okay, this object. So this is available to you automatically in Databricks. This Spark object. Okay, and how is this created? This is a Spark session builder master. A master local means where the deployment is. I'll talk about deployment anyway. There are three modes of deployment of Spark. One is you are deploying it using Yarn as a cluster manager. Second is you are deploying using Mesos as a cluster manager. Third is you are deploying using standalone. Okay, so local means it's a standalone deployment. Okay, here deployment master local. Okay, then you build app name. Okay, you give app name, post app. Okay, config, some configuration related information. Okay, I'll just name it to something else so that it does not conflict with the inbuilt. Understand this is inbuilt. Okay, you cannot have two. Okay, so I'll not execute it. I'll just write the stuff, and finally you'll do a get or create. Right, this will create a Spark object for you. Okay, this using this Spark object you can do a lot of stuffs. Okay, so
So something like is it mandatory to even create the app name? If I create only master, is it enough? Is it not enough?
Yeah, you have to pass here local key. I will tell you what is the reason. Okay. Okay, so I'll explain what is this each thing here. Where is the okay? So first aspect is master. Right. So what is master doing? Set. So yeah. So what is master doing here? Sets Spark master URL to connect, such as locally Okay, so remember you are running it in a clustered environment. So by default, this guy master will connect to the cluster. Got it, right? So URL of cluster. Suppose you are running it locally. That means your driver and the executor running in a local machine. That time you will pass locally. Okay, suppose driver. Suppose everything is running in local machine. Okay, in that case you will call this local. Okay, and you will see this people, you will many times you will see this people are writing this 4. It means run locally with 4 cores. Run locally with 4 cores. Right? So and at times you might have to pass like things like this: Spark master 70%. What does it mean? URL you have a standalone cluster. Right, so just to talk about various types of clusters, okay, so that we can understand these things. Various types of deployment. Okay, one is yarn as cluster manager. Mesos as cluster manager, and you have Spark standalone. Right, so do you guys understand what is yarn as a cluster manager? Okay, so what will happen, you have a deployment. In the deployment, yarn will be doing the cluster management work. Clear, right? Okay, then we have Mesos as cluster manager. Okay, where this is another technology of doing cluster. This was used previous to yarn and still independently it is used in deployments. So Mesos, and the third one is, this one is provided by Spark. This one is provided by Spark and comes bundled. Okay.
So Avantik, what is the difference then in yarn and Mesos?
These are different clustering technology. In what is clustering technology? Some technology which will actually connect a lot of systems and make it in a cluster. So yarn and Mesos are nothing but clustering technology.
Okay, and they come inbuilt with Spark, right?
No, they don't come inbuilt with one. Only the Spark standalone come inbuilt with Spark.
Okay, I think with Hadoop, yarn and Mesos both come.
Yeah, with Hadoop, yarn comes definitely.
Okay.
Okay, but by default, in this system, right, wherever you have installed or whatever you're doing, by default it will be Spark standalone that will be configured.
Okay, like so anything like we can suggest, like when a client should have a yarn as cluster manager, or when they should have Mesos.
So this is typically, don't worry much about it. This is typically DevOps people's job. Okay, so because they will decide which should be the cluster manager for the case. Okay, and it really doesn't matter for a programmer who is managing the cluster. There is nothing like, but this is good for that is good for it. So it is mostly how you want to deploy. That's pretty much based on your network devices. It's purely DevOps works, nothing to do for developers. Okay, you understand it, DevOps?
Yeah.
Yeah, so it is simple deployment related system. It's nothing to do with programming. Just understand that by default Spark standalone will be there. Okay.
So Spark standalone is which is without Hadoop.
Hmm? Yeah,
Spark stand.
Spark standalone is not Hadoop. Right. See,
Okay.
this guy, whenever I'm using Databricks guy, I'm using there is some, see, without even doing anything, you can see that it is already in the cluster. I didn't install Yarn, I didn't install Hadoop, so automatically this is a Spark standalone cluster here.
Correct. Correct. Correct.
Okay, so that is what I meant. So, and when you are configuring, so if you are giving local for, it means you are using you are using local machine. And if you are if you have a standalone cluster, that means Spark's technology, you will give this URL. Automatically in this case it is AWS, so AWS URL. Okay.
Yeah, only, but I mean, like, what exactly, like, what are we setting when we say master? So, what are we setting here?
Yeah, so in case of Databricks, it is automatically set for you. In master, it is automatically setting. Okay, in master, it is automatically setting. See, dynamically, what happens in Databricks, it finds a low cost AWS machine and it connects to this, right? That is how it happens.
Mm-hmm.
Okay, so when you, so that's why, right? Spark, this object is coming inbuilt here, right? Inbuilt.
Mm-hmm.
Okay, so because your this guy, your uh, Spark, I mean your Databricks guy will automatically create a AWS server and it will connect it, right?
Mm-hmm.
So here here in this case by default it will be URL of AWS server that got created. Understood?
Oh, okay.
Yeah.
So so do I always give local here?
No. Local you will be giving in case you want to execute in your local machine.
Okay.
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 And suppose you understood, right? Suppose this is a standalone local machine in one system, right? You don't
Right.
want to do it. I mean, you don't want to create a server. You don't want to create a driver code. You don't do just simple stuff. Then you do local and you pass here for and all. Okay. But in real deployments, okay. But in real deployments, you don't do this. In real deployments, you need URL of the cluster, right?
Mm-hmm.
Right? A cluster should have a URL. You need URL of the cluster. Okay, so what you pass here is URL of the cluster, and if the cluster is deployed using what is standalone Spark standalone, the URL will look like this. If it is deployed using Yarn, it may be looking something like this, like something else. Okay,
Right.
so the next aspect is here conf. So in the API, I use this conf. Right, conf means it is to do with all the configurational stuff. Okay, you can provide all Spark configurational thing, right? Configuration, this will be key, this will be value. Got it, right? It's, you can have multiple of these conf set it out here. Okay, now, okay, and in this case, okay, let me just explain. So in the config, okay, so I was talking the argument here. I'll just explain in a minute. Okay, so here you have config. Okay, so how do you use config? Okay, you use something like this. Okay, Spark session dot builder dot conf dot config, and you will pass here conf is equal to Spark conf. So okay, so this guy config will contain key value pair. This guy will contain all key value configuration here, right? See the way I have written the code here, it will be something like this. Okay, so we won't be writing this code. These things will be automatically generated. Okay, I'll show you one stuff. Suppose if I do this, I do this. So this is a inbuilt document here. Suppose it doesn't have it. Okay, so we'll proceed further. Now we have seen a little bit things here and there. Now let's understand how to create some data frame, how to do some processing. Okay. Now this is a Spark object. You can see here Spark object is there, and what is Spark object? It is a Spark session. So in this particular application, this will be the object which we'll be dealing with, So what I want to do, I want to create data frame. See, I'm creating a data frame now. Okay, to create a data frame, we can pass any list or tuple. Okay, list of tuple. Let me do it. Suppose I write this. Okay, suppose one. Okay, so what it is doing, it is creating a data frame. Now if I collect it, what is collect? If I get all the data in my driver and then connect, see what it did here, right? If I do this simply, now onwards I'll write df. It means data frame. Okay, if you see this, if you see df, it is nothing but your data frame here. Okay, underscore 1 underscore 2. So if you want to get all the content, right? So the same way we had earlier parallelized to create RTD, we have create data frame to create a data frame. You can have a dictionary, pass data in just key value format. It will create a data frame. Okay, there are other ways which can do the same. Okay, you can have a dictionary, right? TP is equal to, okay, name, okay, age,
Uh,
50.
so yeah. So Avantik, actually, I'm still thinking like the one you have created, that MySpark object on the top.
Right.
So first of all, this is what? This is a Spark context object, or
Yeah,
this
so
is a
I mean the reason why I showed you this is because we are playing around with this Spark session object. From here it's right. This is inbuilt present to you. So what I'm
Mhm.
trying to tell you that this is the way by which the inbuilt Spark object gets created. You are telling here where it is getting. I mean where the cluster information. You're telling the app information. You're telling the configuration information, and finally you're doing a get or create, which will create a Spark session. Okay.
Okay, so MySpark is a Spark session, right?
Right. It is a Spark session.
And just one more thing. So this app name can be anything, right? So I can have you have first app. I
Right.
can have anything, or it has to be
Of course,
first.
you can have anything, and whatever name you give in this, argument, that will be shown up in the Spark UI. In Spark
Spark
UI,
UI.
right. By
Okay,
default,
okay.
it will be
And configuration, exactly like why it always has to be a key value pair, or
yeah, so there are two things in configuration. One thing is it can be a key value pair. Okay. Other thing is when we'll be doing this Spark deployment for cluster, right? I'll be showing this information. Okay, this will in real execution I'll be showing when I'm doing Spark in cluster. Okay, some deployment scenario. Okay, and this guy in configuration you have to pass here Spark conf object. Okay, Spark conf object will contain everything how the Spark cluster is configured.
okay, how Spark object is configured. Okay.
Okay, how a Spark cluster is configured, that information will be there.
And this, why this app name is important? Like it only will show me on the Spark UI, but why it is? I'm not.
Yeah, that's it.
What?
That's it. It's not more important than that. Okay, how do you need to separate different apps running in your cluster, right? How do you do that? You do that with some name, isn't it?
Okay. So different app means okay. Okay.
You
Different
can have
app.
a multiple application running in your Spark cluster, right? How do you differentiate which one is what? So this is what you do.
So like any example, like what can be multiple applications?
Yes, yes, you can have. I mean, I'll show you when we are doing Spark
Okay.
cluster. Okay, so that is deployment case. The Spark
Okay.
deployment is very much different. So I'll just put an end on the deployment scenario here because it is a separate topic that I'll be talking about.
Correct. Correct. Correct.
Okay,
Okay.
so let's not deviate. We want to understand data frames now, the way we
Sure.
did our DDs.
Sure.
So now, see, this is how we are creating data frames. Okay, uh, create similar to parallelize, right? Create data frame similar to parallel. Okay, then this is same as almost all the aspects will be working here. Okay, so now you have a dictionary. Of course, you can have a much more bigger dictionary. So whenever you want to do this, spark dot spark dot create data frame, pass here db, because if you pass a db now, see it is creating a data frame from a dictionary as well, and you do collect. What will it do? It will convert this db into tuple list. What happened? Cannot invert schema of type. Oh, I just gave just dictionary, right? It should be like this. List of dictionary. Okay, it should always be this. Yeah. So you can see here, this guy is coming here. Okay. So earlier it was list of tuples. Now it is list of dictionary. It should always be in this format. If you have multiple data, you can do like this. Okay.
Yeah. Yeah. I think that's the same way as we create dictionary in Python, or this is different.
Right, just same with the little list of dictionary in this case. That's it.
Okay. Okay.
Okay, you can see here you get two rows. Clear, right?
Yeah.
Okay, and here you will be having a name here. You don't have a name here, isn't it? See, the difference between this guy and this guy is you don't have a name here. Like it is just what it is telling you. The first element, first rows, first element is Avantik, second element is one. First element is Avi, second element is 200. Here you have a name here, right? So whenever you are converting dictionary to Rizal, you get a name. You don't have this name information earlier. Got it? The differences between this guy.
No, actually, I didn't understand.
You can understand. So let's see this case. So these are ways by which, like we earlier created RDD, we will be now creating data frame. So this is one row. This is another row. So when you are actually converting this into data frame, you don't have a name key information, isn't it? You don't have a key information or other field information. You are not passing here anything. So there is no field information. It will just store the information in order of the first field is this guy, first guy is this guy, second guy is this guy. The first guy is one thing, second guy is one. First guy is Ravi, second guy is 100. Okay. Now, okay, that is why you will have this order because you don't have any uh, name here. Second stuff is you have a dictionary here. Okay. So in dictionary you have get this name. So automatically the a particular row gets the name. A particular row gets the name. Understood?
No, are you saying like in second case, both dictionary are having same field? That's right.
So dictionary these guys, suppose if I do this. Okay, so you can see here, where is it? Yeah, you can see here it added one more field here, but it means how many columns are there in the entire table. Just imagine data frame as tabular data structure. Okay. So how many columns are there? You have 3 columns because 1 guy, 2 guy, and 3 guy. AG1. 1 guy, 2 guy, AG1. This is none here because in this column I don't have any AG1 corresponding information. Right?
Can you just show me that first one?
The first one has no name information. That's why you will find it is _1 _2 because _1 and 2 means the order in which it is.
No, when you say it does not have name information, means you are talking particularly this field name.
No, it means, see, it does not have like in dictionary, this is a key or name. I'm not using the word key because it is confusing. So it does not have a name information here, right? It does not have a column information. Just imagine that it does
Okay,
not have a
okay,
column
okay.
information. Okay. So I'll just write it here. Does not have a column information here because of the way you're passing data here, it gets a column information. Doesn't
Okay, okay.
have column information.
So basically, in the first case, basically all are values. So there's no like key information or column name information.
Right. Here these are column names, and in some cases the column information not there. In that case, it fills as none.
Okay. So that means like it is good to create in a dictionary way because we can get a column names. That's what. I mean, like so, like we can say like it's always like good to create in a dictionary way whenever we creating a data frame.
Yeah, it is always good because you get data in on of tabular format. You can do a lot of processing because of this.
Yeah.
Yeah. So even if you have an unstructured data, it is actually converting that into see structure here. Even if keys are different, it is converting that into structure. Understood, right?
But in first case also, it's like by default, it's like it's giving some column name, row underscore
Right,
one.
right. I mean, both again. I mean, talking about data frames in general, what it does is it converts unstructured data. It tries to convert unstructured data into a structured data. Yes. Column name. Key of.
Yeah. And I wonder like what does it this U comes automatically before you're in the last line
U is for
like U.
Unicode. If you have a
U for
string,
U.
Unicode. Python
Okay.
represents string in Unicode. Like there are two formats: ASCII format and Unicode format. Python represents string in Unicode format.
Okay. Okay. Yeah. Yeah. I think that's a normal Python also does the same thing.
Yeah, everywhere you'll see the same stuff. Okay. So you will see now you have row, isn't it? Each row is represented by this row data structure, isn't it?
Yeah.
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 But
So yeah. So
like
remember yesterday we saw this row. Okay, so import PySpark dot SQL from import row.
Cool.
Oh, sorry, R capital. This data frame consists of multiple rows, isn't it? So we imported this row. Now I want to create a row. Okay, how do I create a row? Suppose I have a hmm, people row name. Hmm. Okay, just see this. This is one row here. Okay, the row which talks about name and age. Let me create one more
So
person.
yeah. So like can we say row is like a class, right? Uh,
No,
so like row.
row is just a row. I mean, just imagine as in Excel sheet you have rows, right? That is row.
Okay.
Okay. Acha, before I get to rows, let me just one thing I need to talk. Okay. So you can convert RDD into data frames and data frames to RDD, right? You can do both.
Yeah. Yeah. Yeah.
suppose you have this RDD equal to sp dot dialyze. You pass some list here. Right. So what you're doing here, you're creating an RDD here. Now you want to convert this RDD into a data frame. You do Spark dot data frame, and you will pass here the RDD argument. Okay, and if you do this, it will be a data frame. Very useful operation because you will be doing this conversion quite everything. Okay, very good.
So one thing I'm just thinking, like, why I might need to convert data frame to RDD. I mean, what can be the reasons? If I want to do it some more granular, but usually I think so. Most of the cases, we would need to convert an RDD into a data frame, but not a vice versa.
Yeah. But many times you need some RDD operations, more precise, granular operation.
Okay, granular. Okay, yeah. As you told us that last time. Okay.
Right. So in that case, you might need RDD. I will give it handy. The first row of RDD is empty.
Okay. And these SQL operations we cannot perform on RDD. These SQLs are only for data frames.
Right. So something else will solve this. The first row of RDD is empty, cannot interact.
I think it is create DF or 2DF. Function name is I think 2DF. It's not create DF. I think it's not create data frame.
No, that is different. That is with RDD. You do this, you'll get this 2DF. Yeah, here it is. This is also created. Okay, no doubt this is also created. Okay. But oh, that is the reason why it is not working, right? Achha, I'll tell you why it was not working. I'll come to 2DF, that is a separate thing. So remember, because it is not working because of this guy. So remember what we are trying to create here. There is some noise. Just mute it for a moment, Ajit. Okay. So remember that when you are creating RDD, your data frames, right? It needs something in the format which can be internally represented in tabular format. Okay. So when you have tabular format, you need to precisely give the column information, right? Or you have to give information row wise. When I gave range, I was not giving information row wise. How do you create information row wise? Let me just do it. Suppose you have L is equal to range. Range 10. Okay, M is equal to range 20. Okay, so if you do this, zip L comma M. Okay, now zip L comma M means it is giving value in key value format. Yeah, now it is fine. Right, now you have DF here. So what is DF? DF is your data frame. And why? So remember, whenever you are converting RDD to data frame to RDD, you need to have data. Suppose if I do RDD dot collect, right, you will see how the data format looks like. And for converting between and among the data frame, your data should precisely look like this. Right, your data should look like this. Key value, I mean, as a row, this is one row, this is one row. Right, now you have converted to data frame. So if you do data frame dot collect, you will get row wise information. See this, you're getting row wise information. This is your one first row, this is first element, this is second element, this is first element, this is second element, this is first element, this is second element. Clear?
Okay. And can you show the output of RDD.collect? What is it? What was the difference?
See, RDD.collect is this data, because you cannot convert. You can only convert. So you can of course have one element. Okay. Okay, you can of course have one element, but it should be in the form of list of tuples format. Okay, this is what it is doing. It is creating a data frame which has 2 columns. Right? It is creating a data frame which has 2 columns. Yeah, is it clear to both? You need in row format. So if you have only one column, right? So you can have data like this, isn't it? 1, 2, 3. Mm, 1, 2, 3. So if you if you are creating an RDD out of this RDD dot, huh? Parallelize D dot parallelize D. So this is your RDD. Okay. Now to create a DF, what will you do? Spark dot create data frame RDD, right? So DF dot collect, right? If I do this, it's all fine. It will be a data frame with only one column.
Okay. But yeah, I think the way we define D is not correct. Maybe it might be. I think the way we define D is, yeah, it has some issue. We don't need to put all the brackets.
I have missed out any bracket.
I think can't we put just one single bracket instead of 3 brackets?
No, you need to have data in. Oh, I have to actually. This was there. Okay, because you generally don't have one column. Okay, so in Python, if you have to represent a tuple, okay, with only one object, you have to do this. Now it will be all fine.
So D is a tuple.
Right. Yeah, now these a list of tuples. Okay, these a list of tuples, and is a list of tuples, and these are tuples. And how do you uniquely mention what is a tuple? See, sets also you write, like if I do this type of
D.
one, if I do this, what will it print? It will print you. So it is printing a int, right? But if I do this,
comma,
right?
yeah, put a comma, yeah, it will be
If I do this, it will be a tuple.
So tuple exactly means what? Just a column, row with a
tuple exactly means an immutable list. That is what is known as tuple. Okay. So this guy, this guy actually create data frame needs list of tuples. Understand? Create